Okay, Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, June 28, 2024. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on a cool and clear summer's evening in my hometown of Rockport, Massachusetts. These Earth and Space reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life-sustaining biosphere, and who wonder about the greater cosmos and all that it has fostered throughout space and time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. They are also in regular rotation on Cape Ann's community access cable television channel hosted by 1623 Studios. I'm grateful for the continuing interest and support shown by Rockport educators and students, Cape Ann cultural colleagues, cohorts of the Gloucester Area Astronomy Club, sundry Earth and space scientists, educators, and communicators around the world, far-flung friends, family, and other curious folk. Thank you for your active participation, comments, and general encouragements. For this episode, I'm honored to be hosting Phil Orbanes, one of the most accomplished astrophotographers within the Gloucester Area Astronomy Club and beyond. Phil first became interested in astronomy while in the 7th grade. His parents nurtured his interest by giving him a fairly decent 4¼ inch reflecting telescope and then by helping him grind an 8-inch mirror for a larger telescope. Phil ended up pursuing a 20-year career in the board game industry, where he achieved great success. Perhaps you've heard of Monopoly? That was his baby. But the lure of observing cosmic wonders under dark skies never left him. So in 2006, Phil moved to a home in Gloucester with a dark view over the ocean. He has since built an observatory there that is equipped with 2 telescopes for both wide field and narrow field imaging. You can see many of his fabulous astro photos on the GAC website by clicking on his name in the gallery section. So let's get going with Phil's presentation entitled Capturing the Cosmos from the Sidelines, a lifetime love of amateur astronomy. Phil, the Zoom platform is all yours.
Okay, let's see if we can share correctly. How are we looking, Bill?
Looks fab.
Okay, let me just offer a word of thanks to Bill for inviting me to do this presentation because it gave me an excuse to put together photographs of my long association with amateur astronomy from the time I was in 7th grade until the present. It's something that I needed to do, and with Bill's encouragement, I've now done it. So the reason that I call this presentation Capturing the Cosmos from the Sidelines is because, unlike Bill, I'm not a professional. My interest in amateur astronomy has been a great hobby, an avocation, if you will, of mine, on and off, depending on where I lived and what kind of conditions I had in the sky. And before I start, I just need to ask you, Bill, I have the, maybe Michael knows, I have the images of the participants in this meeting on the right of my screen, and I need to get rid of that.
I don't see them.
Yeah, well, I have them here.
Oh, and they're in the way?
Yeah, they're in the way of my copy.
Oh,
wait a while, I just did it. Okay.
Great.
And then,
Hey, Phil,
yeah,
they're in your way, but they're not in our way. The presentation is to the left of the pictures.
okay, but you can see my screen clearly, right?
Yes, yes, in its entirety.
Okay, great. Well, I just solved that problem. I'm ready to go. And here we go. So this is by way of introduction. My pursuit of the Whirlpool Galaxy M51 is symbolic of my desire to not only take astrophotos, but to attempt to make them great. And so here's just a few thumbnails of M51 through the recent years, culminating in my image from last year. And in this presentation, I'm going to reprise my multi-year trek along the sideline of amateur astronomy, and then I'll show you a series of what I consider my best photos. So I got hooked in the 7th grade. And after buying two toy telescopes, I persuaded my parents to get me a real telescope for my June birthday. And as it so happened, the Edmund Scientific Company was only 50 miles from home. They had a very nice catalog with a lot of different scientific items, but it featured 3 or 4 different telescopes. And this one looked very impressive in the catalog, and my parents got it for me, which in those days was a very expensive birthday gift that it took a lot of courage on my part to ask for. But the scope was a lot more modest, as you'll see, than in the picture. And here I am with it a few days after my birthday. And I didn't get the really nice metal mount. I got the more modest wooden tripod, but that turned out to be an advantage because most of my observing then was done in plowed fields. So I was able to get it, nice and level, which I probably wouldn't have been able to do with the metal stand. And a couple of years later, I built an observatory. And I did so with the help of my dad and an uncle who was a Mason. And I was in high school by this time, and I was inspired by plans in popular science. So here you can see the scope that I built. And here's a view looking down from the ladder that I used to get up to the eyepiece. It was an 8-inch mirror that I ground and had polished professionally. It was F9, and it was mounted on an angled engine block, which I also learned about through popular science. And my dad, being a machinist and a mechanic and a good welder, he fashioned a stand for it to angle it toward the North Star, and it actually worked surprisingly well. Most importantly, it didn't cost me anything. And I was doing my viewing in my hometown of Goshen, New Jersey, which is in Cape May County, south of Atlantic City. And boy, did we have dark skies. It's not something that I was able to appreciate until after I moved away. I just took it for granted. But there was 16 more years before I got my next scope, and there were no dark skies where we lived in the New York City area. And I was able to justify getting it after we moved to New England and moved to Boxford. It was a 8-inch Celestron, looked like this one. And I took my first photos with it. It was okay for the moon, but little else. And I found these photos just a couple of days ago that I had taken back in 1986. Wow. The following year, I had pretty good success in my job, and I was able to get a 14-inch Celestron. And here's me with it partially disassembled. The good thing about this big, heavy, bulky scope is that the tripod, the mount, and the scope itself all disassembled quickly, so you could take it from inside to outside and set it up without breaking your back. And now I finally had the opportunity to do deep sky imaging, but it really wasn't very easy without computer guidance, and it relied on grainy 35mm film back then. My exposure time had to be under a minute. Even using 2000 speed film, it was difficult to get a good image. But here's 2 of the ones that I did take back then, a streaky star image of M13 on the left, and a first try at M42, the Orion Nebula. But I had to sell this equipment when our kids went off to college, and we decided to move to a condo complex, which of course had perimeter security lighting. And so for the next 16 years, I went dark. But moving to Gloucester changed everything, because now I had this wonderful view overlooking the Atlantic Ocean outside the outer harbor, pointing south from east to west. So every photograph that I've taken since that time is in this very favorable portion of the sky. But learning how to take decent astrophotos does take time. And here, for example, was my first photo with the Celestron 11-inch that I mentioned earlier. To take really good photos, you need good equipment and great software. So after 2 more Celestrons, I knew I really wanted to stick with the hobby this time. And so I bought an observatory kit from a firm, I think in Minnesota, and with the help of 2 friends, put it together. And I still use it to this day. I semi-retired back in 2013, so I had the time to do it. And if I stayed up a little late, it wasn't, going to really affect my work performance. I ended up naming it Cosmic Mariner. And here I am with my son a couple of years later when we put inside of it the 2 scopes that to this day I routinely use. And they are a Takahashi 5-inch wide field refractor and a plane wave 14-inch reflector. They're mounted in tandem on this very, very sturdy Paramount mount by Software Bisque. And it's vibration free. I can walk all around this observatory and never will it vibrate either of the scopes. Each also has a dedicated CCD camera and filter wheel, which saves me from having to shift back and forth. The one sacrifice, if you will, is that I can no longer do visual astronomy as long as I have the cameras permanently hooked up to them. Here's a couple of more pictures of what it looks like inside. Okay, so now I've got what I consider to be good equipment, but the process of turning good equipment into good photos is a long climb, but a rewarding one. And so here, for example, is my next attempt at M51 in 2014. M51, by the way, is actually fairly modest in size. It's only about 1/15 as large as a full moon. And every year from 2014 until around 2020 or 21, I kept at it with M51, adding more and more imaging time in my quest to finally get it to be what I considered as good as it could be with my scope. So here, for example, is my image in 2017. It's getting better. But here's the ultimate. This is what I took, or this is what I processed last year after about 40 hours of imaging over the prior years. And I will explain how I got to this nice, highly detailed image as we go. So first, on the sidelines, you need more than just good equipment. So here's an example of 2 gentlemen who have some very fine equipment. One priority you have to have, of course, is an atlas, so you know where the objects are that are worth shooting. And a good atlas like this one shows deep sky objects in their actual size and in their actual brightness. So if you were to look at this particular section of the sky, there's a lot of nebula in it. The really bright red one is a great object to photograph. It would be an easy object to photograph because of its brightness. But if you got into some of the later objects, you're going to need to have a lot more time devoted to expose them. And you can also see on this particular chart, large dark nebula. So this is the program that I mentioned earlier. The Sky runs my telescope. And is it's the program that finds any object in its database that I want to photograph. Because of the calibration I did many years ago of the entire sky, if I type in, say, M57, M57 is centered in every single time, and it will hold its position for 5 to 10 minutes, which means I don't need a guiding scope, which is a great relief. Now, the most important program initially was Photoshop. Photoshop is a very general graphic tool. It's very powerful. It can be used to sharpen, to darken, to crop, to resize, but it pales in comparison to this program, which is the most important breakthrough in amateur astronomy, probably since the invention of the CCD camera. And that's this program called PixInsight, which gives you immense control over the quality and the processing of your image. And it was specifically designed strictly for astrophotography by astrophotographers. And what's wonderful about it, it's open source. Which means that some really very brilliant third parties have created tools that work within PixInsight of late that employ artificial intelligence, which makes all of our lives easier, those of us who photograph the heavens. Noise, though, is always the enemy. And shot noise comes from, I'll read this, but this is the definition: from the statistical variation of a source's photon emissions over time. This variation leads to uncertainty in the photon count in the signal. Shot noise looks like specks or speckles, splotches, and sandpaper-like grittiness in otherwise smooth honed areas, which basically means the background. If you don't have enough images and the right software, the background is going to be the ruination of your photo. Now, software can reduce it, but there's no substitute for taking lots of images and mathematically stacking them, which, by the way, PixInsight does fairly effortlessly. So lots of stacked images adds to photon count to the signal itself. So there's another advantage if you stick with an image and photograph it for 10, 20 or more hours, as I sometimes do. So here's an example of a few images early on that have too much noise. Here's the Sombrero Nebula in 2015, and here's M107 the same year. And we'll return to these a little later. Also, they had poor color balance. There's too much red in these images, and that's something else that I've learned how to take care of. So you remember those early images that I showed you of M13 and M42. So here are the same images that I took way back in 1986. Here's my first attempt with them when I got back into astrophotography in 2012. And they had the same problems as the images that I showed you on the prior slide, but I learned how to overcome them. So here they are after a few years of schooling, and I think you can see the difference here. That's M13. And here's a close-up of part of M42. Now, the thing that I really am so pleased by PixInsight is that because of its ability to sharpen without creating noise, you can actually, for the first time, enlarge an image that you photograph and make it bigger than what your telescope sees it as. And the background, as you can see in M13, is now very quiet, very smooth. So M13 I devoted 25 hours to, and M42, 40 hours. And you'll remember earlier I showed you the Sombrero and M107. Well, here they are after a lot more hours and better software processing. So M31 has been a pursuit of mine as well. And this is my first image of it back in 2012. As you can see, it has a horrible bluish cast, but at least I did capture the entire galaxy. Here it is a few years later in 2015. And what's notable about this is how blown out is the core still. But by 2017, I had mastered the ability to bring the core back into proper brightness and to sharpen it correctly. And you can start to see now a lot of the detail in the outer bands. One of the things that is notable here is that M32 and M110, the little tiny satellite galaxies, or the M110 is a tiny satellite. You can see that M110 is actually already inside of M31 and eventually will be absorbed. M32 on the upper right is being absorbed little by little. You can see how there's a star bridge between M32 and M31. Now, this is my picture in 2020. That's much smoother. And then here we are, the last, oh, sorry. Let me go back for a second. In 2020, I had finally gotten 42 hours of imaging on this one, and I realized this was as good as I could hope for with my 14-inch scope. But one of the things that I found online were some close-up images of M31 taken by the Hubble. And what I did was I enlarged M31 greatly, thanks to PixInsight. And then I did these comparisons. So these are 4 pairs of images that show what Hubble saw versus what I see with the 5-inch refractor, lots of hours, and really helpful software. Another pair of galaxies that I particularly like and enjoy are M81 and M82 in Ursa Major. And this photograph, again, is about 40 hours. It fits within the field of view of my 14-inch. But what's really wonderful about PixInsight is how I was able to take each galaxy and enlarge it. So this is from the same photograph. Here's M82, and you can see the star bursting going on, which is the product of a close path with M81 many millions of years ago. Globular clusters are something that I found really difficult early in my astrophotography career, but I finally figured out the techniques required to get them to resolve themselves down to the cores. And here's 4. My favorite among them is M22. So here's M22 some years ago, which is looking decent, but it's still got a long way to go. But here it is when I finished it last year. What's so distinctive about this globular cluster is that it is superimposed in front of the Milky Way. Most globulars orbit the Milky Way galaxy from afar, and there usually is no background like this, but M22 offers us this really great visual treat, which is countless stars in the Milky Way facing toward the galactic core. And thanks to PixInsight, I was able to blow up my image. And if you look carefully, you'll notice that even the stars in the center of M42 are resolved. I never thought this would be possible, and I take credit only for having put a lot of time into it. It's really the software that made this, as good as you see it here. So color is nice, but sometimes black and white is more dramatic. So here's the jellyfish. And as you'll see, it's pretty dramatic in black and white, somewhat less so in color. But the other technique that I use a lot with nebula is narrowband. And in narrowband, you don't filter through red, green, blue, and clear. You filter through the wavelength of three different, if you will, elements: hydrogen alpha, sulfur, and oxygen. And you get different coloration. You can process these images with any color balance you're looking for. But what you do get from narrowband is extremely good detail and pinpoint stars. Small objects are always a challenge if you don't have a giant telescope like Mario. But here you can see this is the Draco triplet, which is 3 uniquely different galaxies. And here is Hickson 44, the galaxy group that has 4 different, or actually 5 different members of it. And there's a lot of tiny galaxies in the background if you study this image. And here's a few images from Ursa Major, including one of its notable stars and 4 of its rather uniquely shaped galaxies. And here's 2 more. These are pairs of colliding galaxies. Mario in particular has some really great close-up images of this, which is really beyond the capability of my scope because these are very tiny. This is the elusive Spaghetti Nebula. Now, this is in Taurus, and it's the remnant of an ancient supernova. And you can see why it's called the spaghetti, because of the, well, it looks like a whole bunch of red spaghetti. It's called Simesis 147. And what's interesting about this catalog is you're hard pressed to find the other 146. This is the one that's really notable. And one reason for that is that Spaghetti Nebula is so faint that it eluded astronomers for decades. Here's a really wide field image of all the galaxies in the Virgo cluster. Now, this is actually a mosaic of 2 images that were stitched together in PixInsight. And I'm going to talk about mosaics in a little bit. Here's a close-up of the heart of the Virgo cluster. This is Markarian's chain. And here are all the galaxies of the chain annotated, including the 2 giant ellipticals that Messier discovered, M84 and M86. It should point out that 4438 and 4435 near the center are known as the eyes.
Hmm.
And here's our other neighbor, M33. Here's an image that I took back in 2019, which is not too bad, but I knew it wasn't good enough because it's too pale. It didn't bring out the proper coloration, especially in the core. And so here it is a few years later with a lot more hours, and I finally got the right colors. And 2 more galaxies that are favorites of mine. This one is 4565, the Needle Galaxy, which has this lovely blue halo around it. It's because we're seeing it edge on, and the halo is actually the spiral arms of the galaxy. And it's really nice as well to see the dust lane going through the center. There's also a couple of other small galaxies in this picture, several of them actually. And here's the pinwheel. Pardon, not the pinwheel. Sorry, let me get rid of that needle. That shouldn't be here, the needle. This is the pinwheel. This is actually the size of the full moon. This is pretty big. M20 is a really beautiful emission and reflection nebula in Sagittarius, known as the Trifid. And here is a wide field shot that also includes M25, the open cluster in the upper left. But here it is enlarged, and the detail is really nice, I think, in this picture. And it earned its nickname, the Trifid, because of the three dark lanes in the center of the emission nebula. And once again, if you look at the background, you can see just how perfectly smooth it is. Because I took a lot of hours on this one too. Here is a mosaic of not only M20, but also M8 below and several other galaxies and clusters. As you can see, they are superimposed over the Milky Way because we're looking toward the galactic core. And there's also lots of dark nebulae in this area, all of which have a Barnard designation to them. So mosaics. This is a mosaic of 4 different images, and PixInsight has this wonderful process that will actually stitch together seamlessly photos that have a zone of commonality along the edge. So in other words, if there's a pattern of stars that's the same in 2 adjoining images, PixInsight will identify, it will even, if need be, change the orientation so that the 2 photographs match up, even if one of them was taken slightly askew. In this case, this is 4 images to bring forth the, I think there's a total of 9 objects in this picture, including the tadpole down below. So it's a nice process. It works beautifully. The only problem is, of course, if you have multiple images, you have to take a great number of hours in order to have 4 worthy, in this case, photographs to stitch together. Here's another example of Cygnus. The bright star is Deneb, but you can see as well the Pelican, North America, the nest underneath the Pelican, and a few other objects of note in the upper right. The California Nebula. You have to imagine this one rotated 90 degrees counterclockwise to picture California. Now, I should point out that in images that don't have as much hours of imaging to devoted to it, you don't see the flames coming out of San Francisco and the coast leading to Santa Barbara. So it does look a lot more like the state of California, but here it is in its totality. And this is another favorite of mine. This is a wide field image taken with my 5-inch refractor that shows both the Horsehead Nebula and Flame on the left, and the Running Man and M42 on the upper right, and the 2 bright blue stars in to the left of the Horsehead and up toward the center. Those are 2 of the 3 stars that comprise the belt of Orion. And M42 is actually in the sword. This is the biggest photograph that I ever attempted in final size, and I actually have this mounted and framed in my office. It's 52 inches by 24 inches. It took 10 different images with my larger telescope to get this and stitch it together as a mosaic. But if you've ever looked at Star Atlas, these are 2 very, very large nebulae, which is why it requires so much real estate. And then finally, here's one of the other side of Deneb that also shows the Crescent Nebula. Open clusters can be fun too. Here's the Pleiades. This, I think, was taken with my 14-inch. And here is M44, the heart of the Cancer constellation. Again, this also was with my 14-inch. It's nicknamed the Beehive. It's fun to capture comets when they come along, and I happened to get this comet as it was passing near the double cluster in Perseus. I was a little anxious on this one because its closest approach was actually when twilight started. And I wasn't quite sure how far it would have traveled before the sky was dark enough to photograph it. But I managed to grab it before it zoomed away, which, by the way, was about 30 or 40 minutes later. And this is a very nice comet from 2014 named Lovejoy. I said 15 here. It meant this. Well, actually, you know, it really is 14. Oh, no, it's Comet 2014. I took it in 2015 when it got close enough to Earth. The trick here was exposing this very faint long tail. And that's why the background sky is not as black as I'd like it to be. That's what it took to get it to pop out of the background. Well, the moon can also be fun. And here's a series of photographs that show the moon occulting Aldebaran in Taurus in December of 2016. And the progression goes upper right to middle left and then back again to lower right. And in each picture, you can see Aldebaran getting closer and closer until finally it's just touching the edge of the moon. And a minute later, it disappeared. Eclipses are also a lot of fun, and I took this one the same year. You can see how long it took from when it started at 9:12 p.m. on November 27th, and it reached totality at 10:17, a little more than an hour later. And 10 minutes after that, it was already starting to return to full sunlight. I mean, full glow outside of the Earth's shadow. Stars can be fun. And what's really nice about star photos, like this is one taken with my 5-inch telescope, is it brings out the actual color of every star, which of course helps you to identify its type and its spectrum. So this is the constellation Gemini, and you can see Pollux, the bright yellowish star on the left, and above it, the bright blue younger star Castor. You can also see, you know, the remainder of the constellation. Now here's a close-up of Pollux. It's a giant type K0 star, 25 light years away. Castor is actually a family of 6 stars. It has a very bright main star, but some of the other objects that you see in the blue glow are its companions. It's also much younger than Pollux, but twice as far. Another nice topic is dark nebulae. This one is fairly famous. It's in Sagittarius, I believe. It's called the Pipe. And if you look, you can see the bowl of the pipe in the center, and the stem of the pipe extends up toward the upper right. And the reason why this is such a brownish looking photo is that this is, again, superimposed between us and the galactic center. And the stars in this direction are all quite old. So there isn't really no young, newly born blue stars that would give it a more typical coloration. Instead, we're looking basically at ancient history here. And finally, last but not least, is my personal favorite. And this is the Horsehead region. This again was 40 hours, and it shows the flame, the Horsehead, lots of adjoining nebula, and one of the 3 stars in Orion's belt. I just really like the color balance in this image. And if Mario was here, he would be saying, you know, that's a pretty picture. And that's the way I look at it. This is my prettiest picture. So that's capturing the cosmos. And I thank you all for watching.
That was fabulous.
Yeah.
Thank you very much.
Well, that's very kind of you to say. Thank you very much.
Thanks, this was really great.
Okay, now.
Yeah,
let me
phenomenal,
stop-
Phil. Thank you.
Stop the share. Okay. Any questions that I can answer?
Yeah, I have a question. For the nebulae such as the Horsehead, the last one, is that just through broadband color filters, or did you punch it up with some narrow band?
Yeah, that's a great question, Bill. It's narrow band plus hydrogen alpha.
Oh, you mean broadband plus hydrogen alpha?
Did I say narrow band? I'm sorry. Yeah, no, it's just RGB
Yeah.
and hydrogen alpha.
Okay.
So broadband and narrow band, but only one of the 3, because the if I was to use the oxygen and the sulfur filters, I really wouldn't have captured anything that I didn't get. But hydrogen alpha brings out a much more realistic and saturated red than you can get with just the red filter. So generally speaking, a good nebula image requires RGB plus hydrogen alpha.
Did you do the same thing with M31, the Andromeda
Yeah.
Galaxy?
Yeah, to get the red nebula in M31, that also requires hydrogen alpha. I'll tell you one other wonderful advantage of PixInsight, and that is it creates a synthetic luminance layer. Now, what does that mean? Luminance is black and white. So it's has always been almost required in the past that in addition to taking, you know, red, green, and blue, you also have to take an image with no filter, which is black and white. And the reason you do that is that the luminance image brings out intensity, not necessarily of a particular color, just all colors. It brightens them up. But it also means that you need to devote a lot more time to get something that you're not really going to be able to appreciate because it affects the other 3. It doesn't unto itself become visible. But with PixInsight takes all of the images that you have recorded in all of the colors that you chose, and it turns them into a marvelous luminance image. And what you do with the luminance, once you have it, you just basically add it to the colors you have, and it makes them pop.
Excellent.
I put a link to Phil's current GAC gallery in the chat. If you like those photos, you're going to love these.
Thank you, Michael.
And actually, Bill, would you possibly mind emailing that out? Because I always forget to copy and paste at the end of the Zoom.
Okay, will do.
And I guess, well, I have a question for you, Phil. By the way, those images were just absolutely stunning, and just
Oh, thanks. I appreciate your
halfway through,
endorsement.
I had to turn the lights out in my office and my monitors off just to be able to appreciate them so much. So,
Thank
yeah.
you.
All right, so I take it you're using a monochrome camera, then just exchanging
Yeah, the
film.
CCD camera takes one filtered image at a time.
Yep.
So, for example, you really need to take a minimum of about 30 red, 30 blue, 30 green, 30 HA. That's 120 images to get a decent image. And if you really want to get rid of the noise and smooth out the background, you double that.
Yeah.
But you end up with nothing but black and white images. The processing in PixInsight turns them into the color that they recorded.
I have one quick question. Phil,
Mhm.
well, everybody, these guys, the photographers get together and have their own Zoom session once every couple of months. And I call them the CMOS Geteers. And I wanted to ask Phil, are you doing CMOS or CCD?
Not yet. It's the next step up. CMOS is one of the things that's wonderful about CMOS is you can, if you have a really great CMOS catalog, camera, you don't need all those filters. You can take a full color image and get enough data, if you take enough of them, to pretty much match a CCD. The only reason I'm sticking to the CCDs that I have is because they're working perfectly and I know how to do it. But that would be my next step up.
Cool, thank you.
So, and I know with CCDs do have a higher quantum efficiency as well, so you can
That's
capture.
true.
Have you ever used any like multi-band narrow filters? So for example, I have a multi-band narrow filter I use with my DSLR, which has both the H alpha and the O2 lines.
No, I haven't. Probably because the filter wheel that I have for my camera just has, in the individuals. And but I didn't really know that they had combination filters now. That's pretty cool.
Yeah, it's a fairly new thing, and I can't think of the name off. It's the L-Extreme. I want to say Beta, but yeah, it's gotten
It
great.
could be Beta, yeah.
Yeah, I'll say I've had outstanding success with it because with the DSLR you do have the micro array there, so it's
Absolutely.
not nearly as good as using a single CCD with a filter, but still it's quite good for a DSLR.
Yeah. Well, I used DSLR for a long time, and I especially the one that I think I had from Canon, maybe it was Nikon, that had HA built in.
Yep.
Yeah. The images were, quite good.
Now, you've mentioned PixInsight and have extolled its virtues quite a bit, but isn't there something new that you and Mario have been working with? And
Oh, well, yeah, that works inside of PixInsight.
Oh,
And what Bill is referring to is something that's called Blur Exterminator.
that's it.
This is a process that sits inside of PixInsight. You pay separate for it because the developer needs to recoup its investment. But what it does is it doesn't analyze an image as a whole. It analyzes it little bit by little bit by little bit using artificial intelligence, and it figures out what that particular part of the image should really look like. In other words, it gets rid of all the noise and the garbage and anything else that may be interfering with a perfectly sharp image. And by the time it's analyzed your entire image, your jaw drops. And that's why, for example, I was able to show those images comparing my M31 to Hubble's M31. It's because this process basically says, I know what this image is supposed to look like, and I'm going to render it for you.
Well, the other AI that I'm associated with is Mike Deneen has fun writing poetry on various topics using ChatGPT. So you could combine your AI images with fanciful poetry.
My my 6th grade grandson tells me that a lot of kids in class cheat using ChatGPT to write their compositions or poems for them.
Oh, gosh.
Of course.
You can tell right away. It's got terrible taste.
Yeah.
It has a voice. You can see it. So you can't get away with it. I know they do it, but you don't have to run it through. We've got routines we can run characters through, like 5,000 characters, and it'll tell you what percentage of it was likely written by AI.
Wow, that's
You don't
pretty
even
cool.
have to do that most of the time because, oh, this is that AI guy again. It's like an extra student in your class.
Yeah.
Well, I think if we don't have any other questions, we could move on to Tony. You want to show what JWST has been up to?
Yeah, I mean, I certainly don't want to take out of Phil's.
No, I'm done. Thanks, everyone.
And this is a preview of coming attractions.
And yeah, thank you again, Phil. That was fantastic.
Thank you, Tony.
So this is the first time I have my previous computer just went kaput. It's the first time I'm trying to share something, so I think I'm changing the privacy settings right now. Sorry, one moment.
Yeah, that's what I had to do.
Yeah. I have sorry, one second. I'm gonna have to quit and reopen real quick. I'll be right back here.
Okay. Well, while he's troubling with his computer, Phil, what do you think is next on your agenda?
Well, that's it's a problem, Bill, because every object that is within the capability of my 14-inch scope, I photographed. I mean, there's actually a finite limit of objects that are big enough to look good through a 14-inch scope.
Hmm.
And over the last 10 years, I photographed them all.
Wow.
Phil, how wide is the door on your Explorer Dome?
The door? Oh. I think it's 30 inches, Michael.
You're a little
Well,
small.
there you go.
But see,
Sky's
here's
the
the
limit.
problem. No, the problem, and I've been thinking about this, the problem is it's an 8-foot dome. So the scope is pretty high off the ground on the mount. I mean, off the floor. And the 14-inch scope, believe it or not, is as big as I can get in there. Now, if they only would come up with larger diameter scopes that are just as stubby, well, then maybe I could.
Hmm.
Tony, you're back.
Yeah, okay. And I'm laughing because I saw one of the photos had the plane wave actually kind of protruding from the gap in the dome. So,
Yeah.
okay, so I think I am good to go now. I am going to flip over here. So I am, just as background, I'm working with the FANGS group, which is physics at high angular resolution for nearby galaxies. And we have commandeered the James Webb for about like a third of a week in early June.
Wow.
And so had some previous observations. So we literally have, 50, 60 hours of data. It's, considered one of the largest programs. And we have done, to my knowledge, the deepest dive into the whirlpool ever. This is everywhere from the F115 band, which is, if you divide it by 100, that gives you the wavelength in microns. So this is just over 1 micron, so just in the near IR.
Okay.
And then we're just going to start going up here, 1.4. So we're starting, and I'm going to zoom out a little bit. But it is fun, just like if you have a single image, just to flash from one to the next. We have 1.5, which is pretty astounding. We're starting to see some dust.
Yeah.
And then, unfortunately, some of our observations lost their guide star. So you'll see a number of these incomplete patches, and we did our best to reschedule them as soon as we could, but they rejected our reproposal, and so it won't be until next June that we can fill in the gaps.
Those dogs.
Yeah, STSCI. And then let's see. So then now this is considered the NIRCam longer, so still near infrared. And oops, sorry. And I particularly like these. We're starting to see some of the spurs along the spiral lanes here.
Yeah.
And I just think it looks the 444, 405. This is a narrow band. I'll be doing the continuum subtraction. And finally,
Are those molecules that we're seeing emit?
it is a combination of dust and stars, especially the 3.35 is largely dust. And we can do some, when I give my talk in August, I'll talk about the continuum subtraction. And then finally, we have the Miri bands, and these are probably my favorite. This is showing almost entire. I don't know how it's doing that now. This is showing almost entirely dust. This is showing almost entirely dust grains, largely stars. So yeah, this is just kind of a preview of what we're going to see. And I'm just still pinching myself, but I have access to 24 different bands of the same galaxy on my hard drive right now. So
That's great.
That's awesome, Tony.
yeah, and
Doesn't get any better than that.
yeah, I've been doing the main pipeline reduction, everything. So it's been just like amazing to be the first person in the world to see these data as they come through. And so you all are in the first, dozen or two that have seen this.
Excellent.
Wow. Tony, that was M51?
That was M51.
That's
It's
M51, Michael.
Where's
Yeah,
the other one?
we did we intentionally just did a strip right across the central portion, so it's only about the like central 25 kiloparsecs or so.
Wow.
But we do have spectra from up where some of that like gas tail is coming in as well, and so that's we used all 4 instruments on the James Webb for our observation. So yeah, I'm pretty dang lucky.
It's stoked.
Yeah.
And it's still performing well. Everything's all nicely aligned.
Well, so the biggest issue that we are having so far, as is evidenced by us, is that there are some issues with the guide stars, and we know there's another star in the region in the field of view that'd be better to use, but they don't let us because it's variable. So these are the types of arguments that we're having with them, and it's worked in the past, but they don't let us use it again. So,
How far in advance did you have to book the time, Tony?
so this was approved for the Cycle 2 project, or the Cycle 2, the second year of the Webb, and the proposals are usually due about 9 months prior to that. So it was roughly written right about the time that the Webb was launched.
And is the web available 24/7, or is there a maintenance time?
So unless something goes awry and they have to do a hard shutdown, for the most part, a large portion of it actually is the slewing and some of the mechanical operations and not necessarily exposures. So
Yeah.
that's why even a 30-minute exposure is going to have about typically 3 hours of telescope usage. So
1,000,000 miles away.
is that right?
Yeah. Amazing.
Has the
it has
web
master-
been impacted at all by micrometeorites or anything like that?
Well, it has 1 or 2 of the mirrors. One especially, we know there has been a fairly substantial impact. But the good news is it basically reduces the effective size by a factor of, or by about like 0.5%. So instead of like the individual wants to have like 1.5 meters, for example, it's effectively 1.49 meters or something. So. We'll talk more about this when I talk. I'm going to go through kind of the pipeline processing and the steps that we use, which will be fun for those of you guys who do PixInsight to see the similarities of how they work in both worlds here. So.
Right.
Wow.
So will you be doing that presentation here with Bill Waller?
Do you want to fly me out, Bill?
Oh,
Hey, there we go.
by Zoom.
From Wyoming with my default plan, but I will say that Bill is part of my PhD committee now, so I'll be flying him out at the end of my defense. So
Excellent.
Wyoming. That's where he is. So
Nice state.
well, I just want to end with this comment that I know it takes a lot for you to do all that you have done. The techniques and that was very interesting, but just the pictures by themselves have such an artistic and aesthetic power to them that I think they're worthy of promoting in those regards as well.
You're speaking to me?
To you mostly,
Tony?
Bill, yeah.
Oh, well, that's again, because that means a great deal to me, Bill. And I'm always aware of the fact that somebody else has to look at the pictures I've taken. And generally speaking, they want to see something that's pleasant, and part of my devotion to the processing has been to learn from the example of others, that I've either downloaded their YouTube videos or I've gotten their books or whatnot. And there is some subtleties that make the difference between a somewhat washed out photo and one that just, I wouldn't say makes you say, wow, but makes you say, that's very pleasing. And that's what I generally try for, is just something that has a pleasing balance in the palette.
Some of those images almost had a hologram effect. I'm looking at them on a 65-inch TV, and I could almost feel like I could look around.
Oh, that's pretty cool.
The object. It was, maybe it's drugs. I don't know. It's an amazing thing you've made.
Well, I can tell you that M51 in particular, by the time I finished it, I thought, just like you, that it had a 3-dimensionality for the swirls of the arms and the valleys in between.
Yeah. I mean, when I was in New York, I was right near the Museum of Holography in downtown.
Oh yeah, I've been there.
So to just And I saw them developing over many years and improving it. And I was just always fascinated with that hologram ability to just walk around the object. I mean, New York, as you might already know, is just an incredible place to wander around and
Oh,
see
yeah.
things, museums and things. So yeah, your work is spectacular.
Well, that's, again, I'm humbled to hear you say that, Arthur. Thank you.
Wow.
All right, I think we better end on this note so that it'll fit into the 1623 Studios program.
Have you
And
emailed Tony?
I have copied it, so I will email once I say goodbye to you guys. Thank you, Michael.
Thank you,
Take care,
Bill,
guys, gals.
Tony.
Thank you,
Bill.
everybody. And
Thanks,
Bill,
Bill. That
thanks
was
for inviting me. I really enjoy these.
Happy 4th of July.
Thank you, Patty.
Yes,
Happy 4th to everybody.
Bye-bye.
thank you.
The
Thank
leave,
you, Bill.
the leave button is new.
Yeah.